All right, so as you might know, HTTP is a stateless protocol, right? So that if you have one server, right, your Node.js server or whatever server you have, and you have two browsers, browser 1 and 2, and each one sends a request, right? There's no inherent mechanism in HTTP for it to be able to distinguish one versus another. And this was a problem early on when the web came out, since we wanted to write applications here that would allow that application to enter in kind of like a conversation with a browser, to be able to identify that it's now it's a request from browser 1 or a request from browser 2, and be able to distinguish between them and maintain some stateful information about each request, right? So several mechanisms were studied. One of the ones that became more prevalent is the use of cookies, right? The use of cookies, the mechanism is that the server, right, asks each one of the browsers to store some identifiable information that can then be passed along in subsequent requests, so that the server can tell one versus another. Okay? So the way it works is that if this comes from domain, d1.com, right, and this comes from d2.com, each one has its own domain. The server keeps track of values, right, for each domain. So, for instance, if one comes in from one domain, the server looks up at a local hash table that says, do I know this? Do I know this request from this domain? If it doesn't find it, it says, okay, well, I'm going to create a cookie, right, for that domain, d2.com, right? It makes a note of it, what the value is. It's a unique identifier, and it passes it along to the browser. If the browser agrees, right, the browser will store it locally on a small file, and it keep track of this identifier, 1, 2, 3. And it'll keep track of 1, 2, 3. If they're accessing a domain 3.com, right? So what the browser will do next time around, it keeps track that for domain 3.com, it passes this value along, and the browser says, it's coming from this particular user, right? Or same thing, right? If it comes from a completely different domain, the domain will access the server. The server will see that the browser hasn't passed any cookies along, and it will generate a new cookie 234, right? Which then the browser here will store for d3.com. D3.com, it will store 234, right? So that now in subsequent requests, right, the browser sends in its headers, it sends a cookie header along to the domain. For each one of the domains, right, it will pass along that cookie, so that the browser, the server, can now identify and distinguish one versus another. Okay? Now over here on the server, we need APIs to be able to parse that information, right? And that information is stored in the header. So it'll be a cookie header. It'll be a cookie header, and it passes the values. One server can ask a browser to keep several cookies for that same domain, and for that particular domain, the browser keeps track of all the cookies for a particular server, and it passes them all along, right, in a long string that can then be parsed here on the server side. Okay, that is if the browser agrees, right, agrees to store these cookies to participate in this protocol. Right? Now, on the server side, we use APIs that allow us to parse easily these cookies from these headers. Okay, so that we can tell what are the cookies, and then internally we can create some mechanism, and perhaps instantiate memory objects where we can key them using that cookie, right? So for cookie 1, 2, 3 or cookie 2, 3, 4, we can keep track some server-side objects, right, for our conversation. So here we would have all objects stored for the conversation we're having with the incoming request with ID 1, 2, 3, and then we can have a separate set of information stored again on the server, right? With keyed off of 2, 3, 4. That make sense? Okay. Now, managing cookies all by themselves is very low level. So as always, we create levels of abstraction on top of this low-level framework, and this idea of storing data keyed off of a cookie, right? That idea? It took off. People liked it, and many libraries built on top of this idea and created the idea of a session, right? The idea of a session, right? Where magically, right, all this is going to be abstracted for you, okay? So that when a cookie comes in, all the setting of the cookie, the parsing of the cookie, all that happens automatically for us, right? And what you get at a higher level, you get a session object, meaning your code when it's running in Node, it automatically gets this object, right, which is already keyed off of the cookie, right? Meaning the underlying framework already parsed the cookie, already instantiated an object for you, and it passes it to you in the form of a session object. And then you can just treat it like a hash table, right? You can just put stuff in there and retrieve it later, right? And the parsing and the mapping of the cookies will be done for you automatically underneath the covers, okay? So that your code, if it's talking to this user, right, to this particular set, this cookie, right, they'll get this instance. If they're talking to this other browser, they'll get this other instance, right? But that is transparent to your code. You just get a session object, which is correctly mapped to either this object or that object, or how many there are, depending on how many conversations it's having. That make sense? Everybody okay? Right. So let's play around with sessions, since the security mechanism that we're going to be using is built on top of sessions. Right? One word about sessions, though, is that since they're asking the server to remember things per user, right? It makes your code, it makes your application less scalable, right? Because you're demanding, you're asking the server to be able to remember these things, right? Instantiate objects, right, on its memory, and it's going to be limited by whatever RAM you have running on this server, right? So we try to minimize, whatever we store in the session, right? So that because the more you store in the session, the less scalable your application is, the bigger footprint you would have running on a particular server, right? If it's just 1, 2, maybe 100 users, it might be okay. But if you're talking thousands, hundreds of thousands of users, then certainly becomes a problem if you have to maintain different sessions stored for each user that's coming in here, right? Up to this point, notice that we have been writing entirely stateless applications, right? The server doesn't know anything about any particular user, right? It always goes to the database, yes? Right? It parses the URL, it grabs the ID of the user, right? And then it doesn't really know anything about that particular user. It always goes to the database for the user, retrieves the user, any related objects, right? And then it responds back to the client, right? Those are by nature is a stateless application, right? The server does not maintain any memory, any knowledge of any one particular user. That makes sense, right? But for security, and that's fine, and that most of our applications should be like that, okay? But for security, like this, like being able to identify yourself, we're going to be using sessions. And one of the reasons is that the stateless applications, the only way that we know about our state, right, is because it's encoded in the URL. Yes? Notice that the ID of the user is part of the URL. Right? So that particular thing, that particular information encoded in the URL is kind of it could compromise the application, having that the ID of a particular user, or some identifiable information about the user. typically we want to hide any information that would identify any particular user. Okay, all the other domain objects, okay, we could perhaps encode those in the URL, but any identifiable information about the user, we want to hide any of that, right? So today we're gonna be refactoring our application so that we're not going to encode anything in the URL of the user. Okay, we're going to remove the user ID from the URL. If you remember, we have /user /user ID, yes, for our application, and we needed that because that was the only way that the server could identify the state of the user, right? Because that's the ID. It was not being encoded anywhere else, right? That's the only way. That's the only place where the application ever knew who the current user was, who the profile to show, which websites to show, right? Right? It were all encoded in the URL, and that's fine. Most of our state should be encoded in the URL, right? But security identifiable information should not. Okay, so we're going to remove that and use session instead. We're going to store all that session, all that user identifiable information in the session, stored safely on the client side. Instead, we're going to use a cookie. We're going to use a cookie to be able to identify the user. And it's going to be an encrypted cookie. It'll be a cookie that will have gibberish information, right? That nobody could crack it or know what's in it, right? That will be our identifiable information that we're going to store back and forth. That make sense?